Hey guys, welcome to another episode of Science TV with Mr. C. I again am your host, Mr. C. Here's what we're going to do for the day. Lots of things on the calendar. For class, we're going to start off by doing ion review, going over what we talked about for the last couple of class periods. Talking about when negative ions form when atoms do what with their valence electrons. Please answer these questions in the text box entry at the top of your assignment. I think it'll be up at my area where my floating head is. Once you've got that done, there's a Pearson Realize activity. Looks something like this. More ionic compound here. The common ions we get where where atoms gain or lose electrons. So here are some of the common ones. These should all be familiar with you. Once you get done with that, I believe I've got it set up for you to submit another screenshot of your completed product. Hey guys, welcome to another episode of Science TV with Mr. C. I am your host, Mr. C. Thanks for joining us. First, I wanted to go over a couple of things. You may or may not have noticed that all the assignments for the week were available to you starting Monday at 7 a.m. You are welcome to get them all done on Monday if you want. If you want to wait and go through it day by day, kind of like I have set up, that's great. If you want to do them all Sunday night at midnight, go for it. That's up to you. Your time. You go through these at your pace. There will be videos every Monday, Wednesday, Friday for you to kind of give you a recap. So there's some changes that I did this week for you. Some people on the forum we did requested that they said that they appreciated when teachers opened up everything at the beginning of the week. So we're going to try that. For today, we're going to work on ion review. We've been talking a lot about ions, charged particles. Ion review looks something like this screen here. So just review what we went over the last several class periods. Negative ions form when atoms do what with valence electrons? Well, a negative ion happens when there's more electrons than protons. So negative ions form when atoms gain valence electrons. Those would be all nonmetals. To do this, there's this little submit button you should see in this area here. Click on it, write down the answers, done. Next, we have Pearson Realize activity. You're going to go to this, and like last time, we're going to take a screenshot of the final product. Some reading showing you some common ions and their charges. A little fill in blank thing here. A short video to watch discussing ionic compounds. Some multiple choice questions. You're going to check your answer. At the end, you're going to type in something here. Check. Screenshot this. Submit this. Done. Next, we're going to go over slides 23 to 35, which I'll be going over with you. They start right here. So we've talked about ionic bonds when when atoms gain or lose electrons and become charged. We're going to talk now about covalent bonds. We're going to describe how atoms are held together in a covalent bond. We'll talk about some properties there and explain how they can be partially charged, not completely like the ionic bonds. So we're talking about covalent bonds. The screen's not large enough here for you. This is where atoms are sharing electrons. They're not losing or gaining like they were in the ionic bonds. If you'll remember back to the periodic table, we've said that metals are able to lose electrons. Nonmetals gain or share. So this type of bond is between atoms sharing electrons. It means it has to be all between nonmetals. Also metalloids also share, but they're more uncommon. So covalent bonds normally form between nonmetals. This combination is called a molecule. Neutral groups of atoms join together by covalent bonds. Now the attraction between these shared electrons and protons is what keeps them together. We've talked a little bit about you guys all did really well in the assignment, the electron dot diagrams. They really go to, those show and help us understand why these atoms are sharing these electrons. Now, depending on how many electrons they're sharing, they have different names. If, for instance, we have two hydrogen atoms sharing one pair of electrons, these two electrons here are shared, that's called a single bond. If they're sharing two pairs, it's called a double bond. And if we're sharing three, then of course it's called a triple bond. Let me bring up a little drawing we can show here to help with that. So hydrogen, remember, if we do an electron dot diagram, hydrogen's in group 1. So it has one valence electron. We're going to put 1 for this atom as well. They both have 1. And what they would like to do is have 2 in their outer shell since they're so small. What will happen is these 2 valence electrons will line up right here. So this electron, these 2 electrons here form a stable outer band. Now the paths of these, think of something like this electron here, goes around this hydrogen, comes back around. The same will be similar with this electron here. Okay. Now, oxygen, next, if you'll remember, is in group 16. So that means it has 6 valence electrons. I'm going to choose a different color for the other oxygen atom. Again, this is where it doesn't really matter where you put them. Just doing this for demonstration. So both of them have 6. Remember, we want to have 8 in this outer shell. So what oxygen does is a diatomic molecule. It means 2 atoms will get together to form 1 molecule. They'll share these 2 pairs here. So this electron will spend some time over here, this one over here, and then vice versa. So this one, in order to get 2 in that little spot, will share. This one will also do the same thing. So we have 2 electrons being shared, or a double bond. Finally, we're going to talk about nitrogen. Nitrogen is in group 15. That means it has 5 valence electrons. So we're going to do a little electron dot diagram here. 2 on that side, 1 above, 1 below. There's 5. Do the same with the other nitrogen. Boom, 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 boom. As you can see, we don't have 2 on the top on either one of these. We don't have 2 on the side. We don't have 2 on the bottom. So, in order to become stable, these atoms will share. As you might have guessed, this one will share across here. This one will share across here. Now each side has 2 electrons. Both tops have 2 electrons. Both bottoms have 2 electrons. So they're all matched up. Since it's sharing 3 electrons, 3 pairs, it's a triple bond. That's the different bondings names that we have for them. Hopefully that makes sense. And here's another illustration of kind of what that looks like. If they're sharing 1 pair, single bond. 2 pairs, double bond. 3 pairs, triple bond. This is how you would actually write them too. The H to H, O to O, N to N. Triple bond has 3 lines, double has 2, single has 1. Now, ionic bonds had some properties. They form crystals, they have a high melting point, they conduct electricity when they are dissolved in water. Molecular compounds also have some properties. since they're only sharing, it's easier to break that bond. They have a lower melting point, low boiling point. Salt, which is sodium chloride, an ionic bond, melts at 108 or 801 degrees Celsius. Sugar melts at 109 degrees Celsius. Sugar is a molecular compound. An easier way to do it, salt melts at 801. Water melts at 32 degrees. I'm sorry, 0 degrees Celsius. So there's a big difference there. And then molecular compounds, opposite of the ionic, they do not conduct electricity. If we were in the classroom, I would show you an example of a light bulb. I could put a beaker full of water, have a special light bulb, and I can demonstrate that it conducts electricity where just plain water doesn't. Or sugar in the water would not conduct electricity. So molecular compounds are basically the opposite of ionic compound properties. Now sometimes, water being an example, there's atoms can become partially charged. One side is a charge negative, the other side slightly positive. Nothing like the ionic compound charges, but when this happens, it's called non-polar bonds. Think of this, hydrogen. Both atoms, same size, they share their electrons equally. It's a non-polar bond. There's no negative one side, positive the other side. When we're talking about this unequally shared, the polar bonds, chlorine is a much larger atom than hydrogen. Chlorine is in group 17. So it has many more protons. There's a bigger positive charge in the center of that atom. So it's going to have a stronger pull because there's more of a positive charge in the center than the hydrogen with a single electron. So the chlorine atom is also larger. So that when it borrows that electron, the electron has to go way around the nucleus. So it's around the chlorine atom longer than it is around the hydrogen atom. Cause it to be slightly charged. It's tugging a little bit stronger. So just be aware of that, that there are some bonds that are shared that become partially charged, called a polar bond. Not all of them are polar overall. And this is actually why water sticks to itself. Now this attraction is called the van der Waals force. If you were interested in what it's called, there you go. And here's a short video clip to watch on it as well. Now, that is the notes, the slides for today. Finally, we have molecular bonding review, kind of going over what those slides were just about. Follow the link. I believe it takes you to here. Using this image to answer questions below, you'll have a little submission box here for it. Which bonds up here are showing double bonds? Looks a little bit differently than I wrote it, but kind of goes over the same thing. So which ones, you may need a periodic table to answer these. Which ones are triple bonds? Which ones have polar bonds? Might be a little bit more difficult here. It's only one, there's a hint for you. You compare and contrast O2 and F2. How are they similar? How are they different? Then for the last part, you're going to write, in your answer part, 6. In the corresponding letter, whichever one it may be. 7, 8, 9, 10, same thing. Thanks for watching today, guys. I hope you enjoyed today's video. Hopefully it's helpful. If you have any questions, comments, concerns, please feel free to hit me up on Chatterdoc, or email works as well. Have a good day. Thanks.